We'll be talking briefly about reaction stoichiometry. Stoichiometry is the study of the numerical relationships between chemical quantities in a chemical reaction. And the amount of every substance used or made in a chemical reaction is related to the amounts of all substance in these reactions. And these are dictated by the law of conservation of mass. And we'll talk about how balancing equations by balancing atoms help us to achieve this. The burning of fossil fuels has become a major topic when we talk about global warming these days. Here, we're showing octane reacting with oxygen to form carbon dioxide and water. The coefficients in a chemical reaction specifies the relative amounts in moles of each of these substances that are involved in this reaction. For example, in this equation, 2 molecules of octane react with 25 molecules of oxygen to form 16 molecules of carbon dioxide and 18 molecules of water. We can also say the same as 2 moles of octane will react with 25 moles of oxygen to form 16 moles of carbon dioxide and 18 moles of water. This relationship between octane and oxygen will always represent the burning of octane with oxygen. Limiting reactants. In any chemical equation, the limiting reactant or the limiting reagent is the reactant that is completely consumed in a chemical reaction. And this limiting reactant actually limits the amount of product that is formed. The reactant in excess is any reactant that occurs in a quantity greater than what is required to completely react with the limiting reagent. When performing a chemical reaction, it is often very important to know how much product you will be getting when you use a certain amount of reactant. We call the amount of product that you get from a chemical reaction the yield. The theoretical yield is the amount of product that can be made in a chemical reaction based on the amount of limiting reactants. The theoretical yield is usually a calculated yield. The actual yield is the amount of product that the chemical reaction actually produces. And we can calculate the percent yield by dividing the actual yield by the theoretical yield multiplied by 100% or 100. Balancing and interpreting chemical reactions. When you encounter a chemical equation, you may find it useful to read it as though if it were a sentence, since a chemical reaction or a chemical equation represents a chemical statement. In this example, this could be read: ammonia plus hydrogen chloride produces ammonium chloride. When you are interpreting a chemical equation, for example, this one here, the chemicals on the left are called the reactant. The chemicals on the right of the arrow are called the product. Chemists usually indicate the physical state of each reactant and product with italicized letters in parentheses. For example, gas is represented by G, as with ammonia here. Liquids are represented by the letter L, and solids by the letter S. Chemical species that are dissolved in water are called aqueous, and they are represented by the letter AQ. Balancing chemical equation. Imagine this reaction between hydrogen and oxygen in order to form water. Written like this equation violates the law of conservation of mass because we have 4 atoms, 2 of hydrogen and 2 of oxygen, reacting to form 3 atoms, as shown here. This equation must be balanced and cannot be left as is. Writing the appropriate stoichiometric coefficients on the right and left of the equation allows us to balance the equation. Hence, by adding 2 additional oxygen on the reactant side and 1 additional water molecule, you are able to balance this equation and uphold the law of conservation of mass. As a result, the equation can now be written: 2 moles of hydrogen plus 1 mole of oxygen produces 2 moles of H2O. Balancing chemical equations is somewhat of a trial and error approach. You may find that you will change the coefficient to a particular number and then later on having to change it again. This is not a one-size-fits-all method.